Hi everyone. Welcome back to videos with me. So today what we're going to do is the last possible thing in our chapter, which is linear versus exponential data. So we're going to really look into how do we know data is linear versus exponential. And then we're going to talk about how do we write the appropriate regression equations given the data in a table. We did this last chapter a lot with linear regressions. Now we're going to move it into exponential regressions. So before we get started, I need you guys to take out packet 10, a calculator and a pen or pencil to take notes, which is really important, and your calculator is extremely important. You can't do the packet or the lesson without it. If you don't have packet 10, then you're going to need paper to take notes down. This is a very big note-taking, not an observation type of lesson like we've been going over, so make sure you have paper as well. So we want to tell how a data in a table represents a linear function or an exponential function, a line or a curve. So let's just first, before we get started, let's recap what we've learned so far about the linear and exponential functions. So a linear graph, you could tell, goes straight up in a line, where an exponential function curves up, like the one on the right. A linear function has an x as as a base, for lack of a better term, with an exponent of 1, like it's got a exponent of 1 where the exponential function has an x in the exponent spot. Now, the other thing when we're looking at a linear compared to exponential function, we can see increase or decrease in both of them. The increase here would be a positive slope, where the increase or growing would be your base bigger than 1. Your decrease here would be your negative slope, but your decrease in an exponential function is a base smaller than 1. Now, these numbers outside on the exponential function just have to do with the initial start of a graph, or the initial starting amount of an exponential function, which would be 5 here, or it would even be your y-intercept, and 3 for this one. Where on a line, this would be your y-intercept at negative 5.6, and your y-intercept here would be 4.98. So they both have pretty much the same sort of components. They're just represented in a little different way. All right, and then the last one was our table. If we look at the way a table is represented for a linear function, the numbers in the y go up at a constant rate of change, which means that we add the same number on this side, where in an exponential table, it increases by a common ratio, which is a number that we multiply by. Another observation I'd like you to look at is that a linear function increases pretty kind of slowly or consistently, where an exponential function increases pretty rapidly. So those are other two observations that we're going to have to start making today. But there is going to be a way we're going to justify it and have like a hard number to determine whether or not a function is linear or exponential. So on packet 10, I want you to look at the do now. It's asking you what type of equation would best represent the data in the table. And we're going to explore later how can we be sure. So I want you to write down what you think and why, and pause the video to write it down. Now, did you say it was exponential because the numbers are increasing really fast down here? If you did, that's great. If not, if you're not really sure how to tell in a table, the best part about today's lesson is your calculator can do it for you. So how can we be sure? Well, that's where we're going today. Last chapter, there was a number that we used to tell if an equation was a strong fit for the data. And that number was called our correlation coefficient, or our R value. So what we're going to do today is we're going to focus on how we're going to determine the type of function that fits the data, and then write the appropriate equation by using that R value. So in order to be sure whether a line is the best fit for the data or an exponential function is the best fit, we have to compare the R values. We're going to find the R value for a lin reg and for an exponential reg. Those are what the calculator calls them, but they really just mean lin reg is the equation for the line of best fit, and the exponential reg is the equation for the exponential function of best fit. So how do we do that? Well, we're going to practice first with this do now question, then we're going to do one together, and then you guys are going to have to work on some on your own. The reason why I want to use this is because we've never written an exponential regression equation, so I want to show you how to do that on our Do Now. So to do that, you always are going to make sure that your diagnostics are on because we need our R values. So you press mode and get your diagnostics on, but just make sure that this number, this letter, this word on is highlighted, not off. Pause the video to do that. Now what you're going to do is you're going to put the data into list 1 and list 2. You do that by pressing stat and edit, and you put this into list 1 and this list into list 2. Pause the video to do that. Again, if you're not going to follow along, you're never going to get this information. So you need to do this stuff in your calculator in order to be successful at today's lesson. So this is what your screen should look like after you've plugged it into list 1 and list 2. Now what we're going to do is we're going to press stat, calc, and 0 to get our exponential regression, and then press enter until you get the equation. So you press enter, enter, enter. Pause the video to do that, and you should get this on your screen. If this doesn't come up on your screen, please go back and retry plugging your data in to get back to here. Pause your video to do that. Now, with the fact that it's an R value of 1 means that it's a perfect fit, that we were absolutely correct, that it does represent an exponential regression equation or an exponential function. So that was perfect. That's why we were going to see how to tell whether or not it was a perfect fit. Now the next part is something a little different. I just want you guys to practice is how do we actually write the equation that represents that table. So what we're going to do is we're going to use the little template up here. The A is going to be replaced with 25. That's a multiplication sign. We're not going to use multiplication. We're going to use parentheses. And you're going to plug 25 in for the B. And then this little caret symbol just means exponent of X. So how do we write this in layman's terms or real math terms? We write Y equals 25, and then in parentheses, we put the B, which is 25, and then we put a little X for the exponent. So when we're asking you to write an exponential regression equation, this is how you should be writing it in that form. Pause the video to get this down. So if you haven't copied all the notes, make sure you go back and do that. And then we're going to do one more together, and then you guys are going to complete some on your own. Okay, so these are the different steps. Just know that all the regression equations are going to be rounded to the nearest hundredth, but they're not going to tell you to round your correlation coefficient. You need to do that just to be able to justify your answer. You can't justify unless you have numbers down. Those correlation coefficients are going to help us. So you need to make sure you get each one of those correlation coefficients down for the linear regression and the exponential regression, and then you're going to round it to the nearest 10,000th. The more accurate the number, the better off we are to compare and see which one best models the data. Okay, so let's try one together. So here it is. A real estate agent plans to compare the price of a cottage Y in a town on the seashore to the number of blocks X the cottage is from the beach. Write a regression equation that best models these data. Round all values to the nearest hundredth. Now that means for the equation, not for the R values. The R values are what we're using to justify our choice of appropriate equation. So the Regents isn't going to have any of this on there. You just need to go through all these steps to justify your answer. So in order to do that, your first thing is you're going to plug all the information from the table into list 1 and list 2. Pause it to do that. And your table should look like that. Now you're going to find the R value for your linear regression equation. In order to do that, you have to press stat, calc, and then 4. Pause the video to do that. And your screen should look like this. Now, all we're concerned about right now is our R value. We will get to the equations later, but right now we're really only concerned with this number. So what you're going to do is you're going to round it. You're going to write it down, round it to the nearest 10,000th. Pause the video to do that. And your answer should be negative 0.9874. Now we want to look at our exponential regression R value, and we're going to see which one is stronger so we know that's the appropriate equation to use. So with this one, we have to just press stat calc 0 because all of our data is already in our calculator. Pause the video to do that. And your calculator should look like this. And this is your R value that we're going to copy down, again, rounded to the nearest 10,000th, which would be the 3. So we're going to round it up to 4. So you should have negative 0.9474. So now to choose the appropriate regression equation, we need to look at both of the R values. So which one is stronger? Which one is closer to -1? So thinking about which one's better to get on a test, a 98 or a 94. Those are stronger. Which one would be stronger is how you're going to compare it. The one for the linear regression would be stronger because 90.98 is closer to -1, or negative 0.98 is closer to -1. So we're going to be using our linear regression equation. So what we need to do is we need to go back in our calculator and find that linear regression equation by pressing Stat Calc 4 again. Pause the video to do that. And your calculator screen should look like that. Now this is where we're going to write the equation down. And don't forget, they told us we need to round to the nearest 100th. So that would be the 1, which when we look next to it is a 2, so it stays 1. And then the 9 has a 0 next to it, so it stays 9. So I want you to pause the video and write the appropriate regression equation on the paper. It should look like this. Y equals negative 34739.71x plus 313309.09. Pause the video if you don't have that. Lastly is justification. Now, since our linear regression equation had a stronger R value, that's why we chose it. So you're going to write the R value is closer to -1 for a linear regression equation as compared to the R value of an exponential regression equation. So you're just saying that because it's stronger that it is the appropriate regression equation. So that's pretty much all you're doing today is you're just practicing getting these equations, comparing the R values, and writing the appropriate equation. So just make sure you copied all the notes down from the video and that you are practicing in your calculator. You're going to flip it to the next page and complete the next 4 examples on page 4, 5, and 6, which are examples 4, 5, and 6. Please take pictures of each page and send them back to me either through Remind or email. I really need to see the work you're doing so I can properly assess that you got today's lesson. Make sure that your name is on each page before you submit it, okay? If you have any questions, don't forget you can email me, text me, whatever you need to do in order to clarify it. All right, have a great day and good luck.